Hi guys. Today we're going to take a really close look at standard form. This is the first form that you really discuss for quadratics. This is the form that we used to factor. This is the form that we use to pick out a, b, and c and start completing the square or use the quadratic formula. And so today we're going to take a really close look at standard form and all the things that you could find from standard form and plot on the graph. So we have 2 pages today instead of 3, which is kind of nice. What I'd like for you to do right now is get out your last 2 set of notes. Your last set of notes was titled Analyzing Graphs of Quadratic Functions, and it has standard form all on the first page, and then the previous set of notes is called Equivalent Quadratic Forms, and it's got standard form also on the front page. So what I'd like for you to do is get those 2 sets of notes out, just kind of scan the front sides a little bit about standard form, and then I want you to take some time and try and fill in these blanks. None of these blanks require new knowledge to fill in. They all come from the previous 2 sets of notes, so I want you to get your notes out, pause your video, and try to fill in these blanks. Get as far as you can, and then whenever you're as far as you can, go ahead and turn your video back on and check with mine. So try it out. Okay, so hopefully you were able to get at least a few of the blanks filled in. What I did is I filled in the blanks on mine, and then I also boxed what each key feature should look like. For example, the first one says how to find the vertex, and so I boxed in h comma k because that's an ordered pair that is the vertex for your parabola. So in order to find the vertex, you want to substitute a and b into the formula x equals negative b over 2a. And simplify. And then once you get your x value, substitute that into the equation to get your y. So that will give you the ordered pair. If you're looking for the axis of symmetry, it's just the x value of the vertex. So once you find the vertex, you just put x equals this number right here, and that's your axis of symmetry. The maximum or minimum value is just the y value of the vertex. So again, once you find your vertex, pick out that y value, and y equals whatever that number is the maximum or minimum value. Now, if that value is the largest y value in your graph, then it's a maximum, and if it's the smallest y value, then it's the minimum. If you're looking for how to find the y-intercept of your graph, the y-intercept is always located where x is equal to 0. And it just so happens to be the c value or the constant in the standard form equation. So you write the y-intercept as 0, comma, and then whatever that c value is. And then finally, if you're looking for the x-intercepts, they're always located where y equals 0. So you put 0 in place of y, and then you solve the quadratic function, most of the time by factoring, but you can use quadratic formula or completing the square if you'd like. And then in the end, your x-intercepts are x, comma, 0. A lot of times we end up getting x equals a number, and those are the way that you write zeros and solutions and roots. But when we actually write the x-intercepts, we do want them as an ordered pair. That solution, comma, and then 0. So now go ahead and scroll down. I'm going to keep that page handy, but now I have an example. And I told you we're really looking deeper into standard form. So there's lots and lots of things that we can find today. So our standard form is written at the top, and we have our equation. It's y equals 1/2 x squared plus x minus 12. Go ahead and pick out the a and b and c values. Take a moment to do that. A is 1/2, b is 1, c is negative 12. So, on the first page, it told us that in order to find the vertex, you want to take a and b and put it into this formula. So I'm going to go ahead and do that here. I have negative b, which is 1, over 2 times a, which is 1/2. So negative 1 over 2 times 1/2. Well, that's just half of 2, that's 1. And this becomes negative 1. So that's the x value of my vertex. How do you get the y value? Remember, a common theme in all algebra classes and every math class after that is if you have an x value and an equation, you can substitute your x value into the equation and get the y. So I have y equals 1/2 times -1 squared plus -1 minus 12. -1 squared is 1. Half of 1 is just a half. Plus -1 is like -1. And minus 12 is still minus 12. I can't subtract numbers if one of them is a fraction and the other are whole numbers. I need a common denominator, so I'm going to make denominators of 2. So I have 1/2 minus, I want to put this over 1 and make those denominators 2. So 2 over 2. And then again, with the 12, I need something over 2. So 12 times 2 is 24. So now when I subtract, 1 minus 2 is -1 halves, and -1 halves minus 24 halves is -25 halves. So -25 halves is my y value for the vertex. Okay. Let's talk about the way this parabola opens. Does it open up or does it open down? Remember that you look at the a value to determine that. If a is positive, it opens up. But if a is negative, that means that you've done a reflection over the x-axis, and a will make it, a negative a will make it open down. So it opens up. Like that. The axis of symmetry is the x value of the vertex. So x equals and then whatever that x value is. So what's our axis of symmetry here? It's x equals -1. So this comes and makes our axis of symmetry. What about our minimum value? Since we have a parabola that opens up, what's the minimum value? Well, the max or min is the y value of the vertex. So here's the y value of the vertex. That's what I write. Y equals, and then that y value. So I'm going to take this, and it's going to create this answer. Y equals -25 over 2. Okay. The y-intercept. The y-intercept is located where x equals 0. The c value of the equation is the y-intercept. So 0, comma, and then the c value. So 0, comma, and then what is the c value? The c value is -12. So the way we found that is that -12 is the c value. And I intended to put in pink all the little ways that we figure out the answers to these things. So for example, I know that the graph opens up because a equals 1/2 is positive. So just little things to help us remember how we got these answers. Okay. Now let's move on to the x-intercepts and the roots and the zeros and the solutions. Remember, those are all synonyms, so they all mean the same thing. So when I find one, that means I find all of them. So to find the roots, or x-intercepts, or zeros or solutions, the x-intercepts is located where y equals 0. So substitute 0 in place of y and then solve, maybe by factoring. So let's see if we can factor our polynomial, our quadratic. Now, this is kind of icky looking. And so instead of dividing out 1/2, how do you divide by 1/2? It's the same thing as multiplying by what? By the reciprocal. So the reciprocal of 1/2 is 2/1. So what I'm going to do is substitute 0 for y. I'm going to write my equation, and I'm going to multiply it by 2, and that way I don't have that 1/2 right there anymore. So 2 times 0 is 0. 2 times 1/2 x squared is 1x squared. 2 times x is 2x. And 2 times -12 is -24. Okay. What would you like to do? Would you like to factor, quadratic formula, or complete the square? It is up to you, your choice. I'm going to pause my video. You should do the same and use one of those methods, factoring, completing the square, or quadratic formula, to get the x values for the x-intercepts, roots, zeros, and solutions. So try to complete that part of the process. Pause your video. So hopefully you picked a method that you're comfortable with. I feel like most people will probably choose factoring and finding the magic numbers, which is completely fine. I went ahead and chose something that I thought less people would pick so that you could see how it was done, and I completed the square. I moved this -24 to the other side of the equal sign, so I moved it over here. I took my b value, I divided it by 2 and squared it, so 2/2 is 1. And 1 squared is 1. 1 is what completes the square. When I write it as my factor, I get x plus 1 squared equals 24 plus 1, which is 25. I square root both sides. I get x plus 1 equals the square root of 25, which I wrote as plus or minus 25, but then I realized, square root of 25 is plus or minus 5. And then I split this. I moved this to the other side, and I had positive 5 minus 1 equals 4, and negative 5 minus 1 equals -6. So those were my two solutions. So I write those for x-intercepts as 4, 0 and -6, 0. And then as roots, zeros, and solutions, I write them as x equals and then those numbers. Okay. Let's talk about the graph increasing and decreasing. Remember that these are intervals, so all the x values that are greater than something or less than something. So I'm going to look back at my graph, my little sketch that I have right here. Remember that the axis of symmetry goes right through x equals -1. So what's happening on the left side of this parabola? From the left to the right, the graph is going down. So that means that all the x values to the left of -1 or less than -1, those are decreasing. Now, once it hits the axis of symmetry, what happens? The graph starts to increase. So if the graph is increasing on the right, that's all the x values that are to the right of -1 or greater than -1. My domain, all the x values, unless I have endpoints here and not arrows, my domain is always going to be all real numbers. And I meant to put here that this is from the axis of symmetry. My range, I need to look at the max or min and determine what my range is. So my range, if I look at my minimum value, Here's my minimum value. It's all at the bottom, so everything else is above or greater than or equal to this. So I'm going to rewrite this, but I'm going to choose the greater than or equal to sign because that's where all of my y values are. They're greater than or equal to negative 25 halves. And then finally, I need to put this in vertex form and root form. Well, root form is probably pretty simple because in root form, let me move this up a little bit. I already started to factor, and some of you guys at home might have factored already. So root form is kind of easy. So we divided out the GCF, which was 1/2, and that's kind of like multiplying by 2. So 1/2 sits out in the front. That's your A value, remember, up here. And then the two roots were 4 and negative 6. So I changed the signs and I put them in factors. So x minus 4 and x plus 6. So for root form, make sure you use the A value that your problem came with, one of your roots that the problem came with, and the other root that your problem came with. That's how we got our root form. And then finally, we need vertex form. So let's go ahead and substitute all the pieces where they belong. A is 1/2. H and K come from the vertex. Remember, the vertex was, there we go, -1, comma, negative 25 halves. So this should be -1, and this should be negative 25 halves. So if I put all the pieces together, y equals A, which is 1/2, times x minus -1. Well, x minus -1 is x plus 1, right? Minus 25 halves. So that's my vertex form, and that's what I'm going to write here. So you take all the pieces that you know and you put them in the right place based on the form that it asks you for.